Hey guys, this is part 2 of the Unit 3 review videos. So on this problem, we're asked to find the second derivative of y with respect to x if x squared plus y squared is equal to 25. And the way we're going to do this is first we're going to find the first derivative, and then we're going to take the derivative again to find the second derivative. Keep in mind that we're taking the derivative with respect to x both times. So the derivative of x squared would be 2x dx dx plus the derivative of y squared would be 2y dy dx, and as always the derivative of a constant is 0. Dx dx is just 1, so this is really just 2x plus 2y dy dx equals 0, and I need to isolate dy dx, so I can subtract the 2x over 2y dy dx equals negative 2x. Divide both sides by 2y, so dy dx equals negative 2x over 2y. You can cancel out those 2's and get negative x over y. At this point, I'm going to rewrite this equation, dy dx equals negative x over y. Right now I have the first derivative. If I want to get the second derivative, I just need to take the derivative again. So take the derivative on both sides. Derivative of the first derivative is the second derivative. On this side, I'm going to have to use the quotient rule. So on the bottom, I'm going to have y squared, and then I start with y on top. Derivative of negative x would be negative 1, and then I'm going to do the top times the derivative of the bottom. Derivative of y being dy dx. At this point, I need to take my expression for dy dx and plug it in for dy dx. So the second derivative of y with respect to x would be negative y minus negative x times, instead of dy dx, I'm going to plug in the expression for dy dx, all of this over y squared. Now you could simplify it further, but you definitely don't need to. The next topic we're going to discuss is if you have two functions that are inverses, how do you find the derivative of the inverse function? So on this picture over here, you can see that we've got an original function f, and then the inverse, f inverse of x, which is a reflection over the line y equals x. Remember that any point f has an image point, basically meaning that if it's x and y here, you can switch the x and y to get the point on the inverse. Now, if you look at the slope at both of these points, they're both positive, but they would end up being reciprocals of each other. This is the formula you're going to want to remember and be able to apply. So if f and g are inverses of each other, and you want to know the derivative of the inverse, you do 1 divided by f prime of the inverse. So let's look at a couple of examples. And before we do that, let's talk about different ways the AP exam would describe this. So they might say f and g are inverses. They might say given f, find the derivative of the inverse at a value. They might say g is equal to f inverse for all values of x. Find the value of g prime, something like that. All right. In this first example, it says f and g are inverses. Find g prime if f of x is equal to x cubed plus 4x plus 7. All right, so the formula that we're going to want to be using is the one from the previous slide. So if f and g are inverses, g prime of x is equal to 1 over f prime of g of x. So we're going to need a couple of different things. We're going to need a point that's on f and also on g. We're going to need a rule for the derivative of f, and then we're going to start plugging things in. So let's take the derivative of f, because on the bottom it's going to be f prime of something. So f prime of x would be 3x squared plus 4. So if I want to do g prime of 7, it's going to be 1 over f prime of g of 7. So I also need to know what g of 7 is. Now, if f and g are inverses, that means that there's a point on f where the y value is 7, and there's a matching point on g where the x value is 7. And whatever the x value is here is going to match the y value here. So I would take f of x and set that equation equal to 7. Now in this case, you can see that at x equals 0, 0 plus 0 plus 7 would equal 7. So on f, there's a point 0, 7, which means on g, there's a point 7, 0. So g of 7 is 0. So we can say that this is going to be 1 over f prime of 0, and then I can just plug 0 into my equation for f prime. You can stop here or you can simplify. You might also need to use a calculator to solve one of these problems. Everything works exactly the same, so you're going to want to find the derivative of f. F prime in this case would be 5x to the 4th plus 2. You're going to want to find a point on f and g so that you can figure out what g of 15 is. So there's some point g that's 15 comma something that's going to match with a point that's something comma 15. So whatever this is going to match this. Now I'm not going to go through the whole thing again to get the calculator, but to get g prime of 15, we're going to do 1 over f prime of g of 15. G of 15 is going to be found by figuring out which x value is going to make this equal 15, because that'll give me this x value, which will also go here. So on my calculator, I'm going to solve x to the 5th plus 2x equals 15. Once I know that number, it's going to go in both of these spots, and then I'm going to plug it in. I've got it all worked out on this next slide. The last topic for this unit is taking the derivative of inverse trig functions. I like the triangle method. You can also memorize some formulas that I'm going to show you on the very last slide. So the way that we're going to take the derivative of a trig inverse function, or an inverse trig function, is to get rid of the inverse trig by taking the inverse of it on both sides. So if I start with y equals tangent, let me give myself a little bit more space here. Y equals tangent inverse of x. To get the tangent to the other side, I can just take tangent on both sides. So the tangent of y is going to equal tangent and tangent inverse cancel each other out. So it's just x. And at this point, we'd want to make it a fraction. So then off to the side, I'm going to draw a triangle where the tangent of y is equal to x over 1. Keep in mind that tangent is opposite over adjacent. So my opposite would be x, my adjacent would be 1. Using the Pythagorean theorem, we could find that the hypotenuse would be the square root of x squared plus 1. Going back here, I'm going to use implicit differentiation to take the derivative on both sides. So the derivative of tangent is going to be secant squared of y. And then remember to use the chain rule, so the derivative of y is y prime, or dy dx. The derivative of x is just 1. To get the secant squared to the other side, you can either divide by secant squared, or I like to multiply by cosine squared of y. The ratio for cosine is adjacent over hypotenuse. So y prime, in my picture over here, the angle is y. So adjacent is 1, hypotenuse is the square root of x squared plus 1. So cosine squared means I'm going to do adjacent over hypotenuse squared. You can leave it like this or simplify. Or you can memorize the formula. In this case, memorizing the formula is probably easier. But when the problems get a little bit harder, I think it's easier to use the triangle method than to try to memorize the formula, because a lot of times you'd have to simplify it. Now, that being said, if it's free response, you're not going to have to worry about simplifying anyway. This problem's a little bit tougher, but the main idea is the same. So my first step would be to move this 1/4 over. So 4y equals secant inverse of x over 7. To get rid of secant inverse, I'm going to take the secant on both sides. So the secant of 4y equals x over 7. Secant is a reciprocal of cosine. Cosine would have been adjacent over hypotenuse, which means secant is hypotenuse over adjacent. So I need to draw a triangle that has a hypotenuse of x and an adjacent of 7. Now keep in mind, if we put x on the hypotenuse is always positive, so we want it to be the absolute value of x. And then over here, Pythagorean theorem, we can do x squared minus 7 squared, which is 49. This time the angle is 4y as opposed to just y. All right, now we can take the derivative. So the derivative of secant is going to be secant of 4y, tangent of 4y, and then the derivative of 4y is 4y prime. Derivative of x over 7 is just 1/7. You can think about x over 7 as 1/7 times x, so the derivative would just be 1/7. So to get y prime by itself, I can either divide by secant and tangent and 4, or, like I said before, I like to multiply by the reciprocals. So instead of dividing by secant of 4y, I'm going to multiply by cosine of 4y. So I've got my 1/7. When I move this secant to the other side, it becomes a cosine of 4y. When I move this tangent to the other side, it becomes a cotangent of 4y. And then I also need to divide by 4 or multiply by 1/4. Now, we can't just leave it like this. We need to figure out the ratio for cosine of 4y and cotangent of 4y. Cosine is adjacent over hypotenuse. Cotangent would be adjacent over opposite. So I've got I'm going to move this 1/4 out front. 1/4 times 1/7. For cosine, I'm going to do adjacent over hypotenuse. So 7 over absolute value of x. And then for cotangent, adjacent over opposite. So 7 over the square root of x squared minus 49. You could stop here. You could cancel out these 7s and simplify it a little bit. Now, anytime you're dealing with the trig inverse functions, you could just memorize these formulas if you want. And that's fine if you like memorizing formulas. I honestly think it's harder to use the formulas on some of those problems, though. Hope this was helpful. Good luck this week.